Hello everyone, I'm Antoine Vastel, Head of Research at Datalo, and today I'm going to talk about bot as a service and how we block them using machine learning at Datalo. A few words about Datalo. We are a cybersecurity company that protect websites, mobile applications, and APIs against all kinds of automated threats such as account takeover, denial of service, ad fraud, and card cracking. So today I'm going to talk about bot as a service, but before that, let me give you some context about bad bots, about the bot detection techniques and signals that we use to detect them, and finally I will conclude by showing you some real-world example of bot as a service in the wild. What does a bad bot look like in 2022? First things to know is that bad bots will target every endpoint of your infrastructure. Let's say you have an infrastructure with some APIs exposed. These APIs can be consumed by mobile apps, by web apps, or used to generate dynamic HTML pages. Most of the time, attackers will start by targeting your APIs because that's where they can find structured content. So you can secure it, but that's not enough. It's also important to have a reliable client-side detection because attackers can automate mobile apps or web apps to get the content if it's also accessible there. So it's also important to have advanced JavaScript fingerprinting or SDK to protect your client-side endpoints. Bots use the same technologies as humans. It's really easy to spawn automated headless browser in the cloud using a product or using open source library. And these browsers have similar fingerprints as the browser you use. Attacks are also heavily distributed. As you can see on the map on the screen that shows an attack that occurred recently on one of our customers, bots were operating from millions of IP addresses, and each IP address made only 1 or 2 login attempts, which means that traditional rate limiting policy is unsuitable against this kind of attacks. Bots use clean IP addresses. What we see on our customers is that more than 30% of the bot traffic comes from residential IPs. These residential IPs are the same IP addresses than the one we use to browse websites. So it's more difficult to detect and block bots operating from these IPs compared to bots operating from data center IPs. Bots can also pass CAPTCHA. They can pass CAPTCHA using CAPTCHA farms, services such as 2CAPTCHA, for example, or using image recognition techniques. All these services are available using popular packages, open source popular packages, so can be easily accessed. And the last change, significant change, is about bot as a service. More and more bots are developed using these services. But what's a bot as a service? Services in the bot field are not new. You could easily find a lot of services to spawn headless browsers, access residential proxies, for example, such as Luminati, or CAPTCHA farms such as 2CAPTCHAs. The real change is that all these services have been bundled into single services that enables to easily make bots without having any bot development expertise. And this trend is visible, for example, with Luminati that decided to rebrand as Bright Data. Luminati used to be one of the biggest residential proxy provider in the world, and they rebranded themselves as Bright Data. Now their product is not only about renting or selling proxies, it's an API, it's a bot as a service that you can leverage to easily make bots. Instead of having to leverage proxy rotation yourself, creating bots, etc., you can just make an API call and they will take care of forging the fingerprints, rotating proxies, and you only pay for successful request. And it's not only about Bright Data. You have a lot of scrapper bot as a service, you have a lot of scalper bot as a service, so bots that enables you to get limited edition sneakers, for example, gaming consoles as a PlayStation. But how does it work? So to illustrate this point, let's consider a scrapping bot as a service. Traditionally, if you wanted to develop a scrapper, you would have make a request with to the URL that you want to scrape, so directly to the website targeted. With bot as a service, instead, you will make an API call to the bot as a service, and you will provide the URL that you want to scrap, along with other parameters such as whether or not you want to use residential proxies, the location of the proxy, whether or not you want to execute JavaScript, etc. Then the bot as a service will spawn several bot agents with different fingerprints, different proxies, and will take care of making several requests to the URL that you want to scrap. It will take care of forging captcha if needed, and it will get back to you with the response, and you will only pay for a successful response. It means that it doesn't matter if the bot as a service had to make 30, 50 requests to go through any kind of protection. You only pay for successful response. You don't need to take care of proxy rotation, of spoofing your fingerprints, of managing infrastructure to spawn several headless browsers. All of the difficult part is handled by the bot as a service. So how can we detect bots and bot as a service? There are three main families of signals that I will present more in details just after. We have the signatures that can be collected client-side or server-side, behavioral signal, and reputational signals. So one kind of server-side signatures is HTTP headers. We can use, for example, the order of headers, the absence or presence of headers, as well as the consistency between the headers sent and the identity claimed in the user agent. Let's say you want to develop a bot using Python request library. Because you don't want to be detected solely because of your user agent, as a bot developer, you are going to modify your user agent. Maybe you will pretend to be Safari, and you will send some fake headers. So let's say you lie and you pretend to be Safari and you send this accept header. Our bot detection engine can detect that there is an inconsistency because this accept header is only present on Chromium-based browser and you pretend to be Safari. So we can flag and block the request. We can also leverage client-side to collect more signals, such as browser fingerprints or behavioral signals. It enables us to collect information about the GPU brand, for example, the list of plugins, but most importantly, we can collect specific challenges that can quickly detect headless browsers and automated browsers. It helps to detect, for example, Selenium or modified Selenium, Puppeteer or modified Puppeteer, such as Puppeteer Extra Stealth, as well as the main headless browsers, such as headless Chrome. That is really important because all bot as a service have options to execute JS in the cloud using these frameworks or these headless browsers. So it's really important to have JS challenges that enables to quickly detect these browsers. Client-side can also be used to collect information about users' behavior, such as mouse movements or touch events that can be leveraged to analyze the user behavior and detect whether or not it is linked to bot activity. And finally, another kind of signal is reputation-based signal. Reputation can be defined at several granularities, such as the IP address or the session. We can extract signals linked to the IP address, such as whether or not it's residential or data center, and whether or not the IP has been recently flagged as a proxy or not. It is really important, once again, because all bot as a service have options to use residential proxies. When you use residential proxies, it costs you more credits, but you have more chance to have your request go through any kind of detection. So it's really important to have machine learning models capable of detecting if a request originates from a residential proxy. Okay, but how do we use these signals? So let me show you an overview of our detection engine. Whenever we receive a request, it will first be enriched. For example, we will add information about the IP address, its location, its autonomous system, a reputation, whether or not it has been classified as a proxy recently. And then, in parallel, we will execute a set of different approaches to classify whether or not the request is linked to bot activity. First, we will verify if the request comes from a verified bot, such as Googlebot, or if it matches any rules created by the customer. We will also verify if the requests match a non-bot signatures. This enables us to quickly detect the less sophisticated bots. And then we also apply a set of machine learning techniques, which I will detail more in the next slide. We combine all the decisions and provide a response. So do we want to allow or block a request in less than 2 milliseconds? When it comes to machine learning, our philosophy of machine learning at Datadome is to have a huge set of machine learning models, each one responsible for a dedicated task. For example, we will use supervised machine learning on fingerprints to detect inconsistent or suspicious fingerprints. We also use supervised machine learning to generate an IP or a session reputation. But we not only use supervised ML, we also use unsupervised techniques such as outlier detection to analyze IP address or session behavior and to classify whether or not the behavior is legit or is linked to bot activity. Finally, we also use semi-supervised techniques to fight against adversarial bots that try to bypass detection, for example, when bots try to leverage captcha farms. All these models generate a score, so probability of being a bot or a human. We combine all these scores using a technique called model stacking, and it enables us to have a single probability to classify whether or not you're a bot or a human. Okay, so now that I showed you the main signals and how we can detect them, let me show you a real-world example of how bot as a service can impact a website. So the example I will show you comes from an e-commerce website that got attacked recently by a bot as a service. The attack lasted more than 19 hours from 3 in the morning to 9 p.m. and generated millions of requests with spikes of traffic of around 150,000 requests per 10 minutes. The attack was heavily distributed. As you can see on this map that shows the location of the request, the attacker used more than 500,000 distinct IP addresses, mostly residential proxies. So, if we look more in details, we see that the majority of the requests comes from Europe. This is really interesting because the website targeted was a European e-commerce website. It means that the attacker leveraged European IP addresses to appear more human, to bypass, traditional geo-blocking rules. The attacker leveraged IP addresses that were located in the same country as the website targeted, or in countries located close to the location of the website. And that's the power of bot as a service. That's something really easy to do. You just need to specify the fact that you want residential proxy and the location of the proxies in your API call, and you can easily access to IP addresses that makes you look more human. So, to conclude this presentation about bot as a service and bot detection, a few points. So, bot as a service and human use the same technologies and IP addresses. It requires advanced browser fingerprinting to be able to quickly and reliably detect whether or not a request comes from an automated browser. Because all these bots as a service have options to automate headless browsers in the cloud. It's also really important to have reliable machine learning models that can quickly detect whether or not an IP address is used as a residential proxy. Because as I showed you on the previous slides, attackers will have access to a huge pool of residential proxies that can be located in the same country as the website or the mobile app they target. Moreover, all bot as a services have options to generate fake mouse movements, fake behavior to appear more human. So it's also important to have a detection engine capable of analyzing a huge set of signals linked to user behavior to detect whether or not it's a fake behavior or a human legit behavior. And finally, I would say one of the most important points is to be able to handle a huge set of signals in real time. The real time part is really important. When it comes to scalper, when it comes to scrapper, to credential stuffing attacks, you need to be able to quickly take a decision. It's not enough to be able to classify traffic afterwards. You need to be able to classify the traffic in real time and block it. Otherwise, it's too late. If the attacker can make a request and it goes through, it can get access to product information or make a successful login attempt. So you need to be able to block the attempt in real time. Thanks a lot for your attention.